Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Consecutive Non-Consecutives, Disjoint by PageDo. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region, which is a box. We have non-consecutive rule set, where cells that are orthogonally adjacent cannot contain consecutive digits. And what orthogonally adjacent means is that they share an edge. So these cells are orthogonally adjacent. These cells are not. They are diagonally adjacent. But orthogonally adjacent cells, which means cells that share an edge, cannot contain consecutive digits. So, for example, if this were a 6, this could not be 5 or 7 here, here, or here. That's not allowed in this entire puzzle. So no cells that are orthogonally adjacent can contain consecutive digits. We also have cells connected by a pink red band line form a set of consecutive digits in any order without repeats. So, for example, if this were, say, a 6, this would have to be 5 or 7. Again, they are not orthogonally adjacent, so that satisfies the non-consecutive rule set because they're not sharing an edge, but they have a red band line, so therefore they must be consecutive there. And that's an example of how red band lines work. We have digits in circles form a set of the digits 1 to 9. There are no repeats. So there are no repeats in the circles also, in addition to normal Sudoku rules of no repeats in a column or a row or a designated 9-cell region. We have cells joined by an X sum to 10, and cells joined by a V sum to 5. Cells joined by a black dot, which is black crop key dot, otherwise known as, one digit is double the other. And not all X's, V's, or dots are given. So as examples, if this were, say, a 3, this would have to be a 7. If this were, say, a 4, this would have to be 1. This would have to be 7 because this adds up to 10. This would have to be a 1 here because they must add up to 5. If this were, say, a 4, this would be 2 or 8, because these must be in a 1 to 2 ratio between them. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, what I like doing, particularly with XV puzzles with X and V's, particularly a lot of them, is start mapping out where particularly the V's have to be. The digits 1 through 4 have to be, which are I consider low digits. So they're always next to digits that are in a V situation, right? Because the digits that can add up to 5 are specifically 1, 4 as a pair or 2, 3 as a pair. And no other digits satisfy that in normal Sudoku. Well, in this lower left-hand box, what digits are possible to be 1 through 4? We have 2 here, because they must be surrounded by V. There has to be 1 around the 10, right? Because you have either 1, 9, 2, 8, 3, 7, or 4, 6, adding up to 10. And there must be another one here because of the same reasoning. That means the remaining digit in this box cannot be 1 through 4. They have to be 5 through 9 here. So this digit is consecutive with 5 through 9, therefore it must be 4, 5, 6, 7, 8, or 9. Okay. The V's, since consecutive digits can never be no orthogonally adjacent cells can contain consecutive digits, all the V's can never be 2 and 3, right? Because they would be consecutive and they would be orthogonally adjacent to each other, which means sharing an edge. So this must be a 1-4 pair this must be a 1-4 pair, and this must be a 1-4 pair because of that. This 1-4 adds up with 6 and 9 to add up to 10. The remaining digits in that add up to 10 cannot be 1 and 4. It has to be 2, 8, or 3, 7. So this is either 2, 8, or 3, 7 as a pair. That eliminates 7 and 8 in the rest of the box, so this can't be 7 or 8. Therefore, this is 5, 6, or 9. If 5 or 6 were in the middle, you would guarantee a 5 or 6 in one of these two spaces. But that would mean 5 and 6 would be in adjacent, orthogonally adjacent cells, and that 5 and 6 are consecutive. So this cannot be 5 or 6, this must be 9, which makes this not 9 and this not 9. This 5 or 6 is only consecutive with 4, 5, 6, or 7. This cannot be 1, 4, 1, 9, or... We cannot have a 1, 4 in the rest of this box because of the 1, 4 pair. So this has to be 2, 3, or 7, 8, adding up to 10. What else do we have? In this upper... Oh, no, we don't have any information there. Actually, we do have information, kind of. Where is the 5 in this upper central box? It cannot be next to an X, because 5 can never be next to an X, because it only adds up to 10 with 5, and therefore you would have a repeat in a row or column. So 5 has to be here. Same, it also can't be next to a V. So 5 has to be one of these two, for that reasoning. 5 can't be here. This cannot be 1, 4, or 1, 9, or 4, 6 because of the 1, 4 pair in the row. So this is 2, 3, 7, or 8. 2, 3, 7, 8 is consecutive with 1 through 4 and 6 through 9. Okay. Same here. And it cannot be 5, 6, or 9. So it's 1, 2, 3, 4, 7, or 8 as possibilities here. Interesting. 1 and 4 is only consecutive with 2, 3, or 5. So this is 2, 3, 5, 2, 3, 5. Where can 5 be in row 5? 5 can never be next to an X because it adds up with 5 to add up to 10. 5 can also not be next to a black Kropke dot because if you try to have it in a 1-to-2 ratio with another digit, it can't be. 5 is double of 2.5, which is not a digit. And if you double 5, you get 10, which is not a digit. So 5 cannot be any of these. 5 cannot be any of these. 5 can't be here because it's not consecutive with 2, 3, 7, or 8. So 5 has to be one of these two, and this can't be 5 because one of these cells has to be a 5 in the upper central box. So this must be a 5 here. Therefore, this is 2 or 3 here. um... 6 and 9 is... Okay, this has to be in a 1-to-2 ratio. 9 is never in a 1-to-2 ratio with another digit, because if you have 9, you get 4.5, which is not a digit. If you double 9, you get 18, which is not a digit. Therefore, this is 6, this is 4, this is 1. 6 is in a 1-to-2 ratio only with 3, so this is 3. This 3 eliminates 3 here, so that's 2. 2 can only be consecutive with 1 out of 1 or 4, so this is 1, which makes this 4. This can't be 2. It cannot be 4 or 6 because it's consecutive with the 5, and also the 4 is in the box. This can't be 4 or 5 because of the 4 or 5 in the box. So this is 6 or 7. This 6 eliminates 6 here, so it's 5, which makes that 6. 5 is only consecutive with 6 out of 5, 6 or 7. 4 is only consecutive with 3 or 5. So this is 3 or 5. This cannot be 1 and 2 in a 1 to 2 ratio. It's either 3, 6, or 4, 8. But if this were 8, this would be force this to be 2, so this can't be 8. If this is 3, this can't be 4 because of the 4 in the column. So if this is 3, this must be 7. If this is 6, this must be 4. 3 and 6 is only in a 1 to 2 ratio with 3 and 6. So this is a 3, 6, 3, 6 pair, which eliminates 3 and 6 in the rest of the column. This can't be 3. Which means this, and you can't have a 4, 6 pair here because of the 3, 6 pair already in the row. This can't be 4, 6, it can't be 3, 7 because of the 3, 6 pair in the row. And it can't be 2, 8, this must be 1 and 9. And this can't be 9 because of the 9 in the column. So this must be 1, which forces this to be 9. So this can't be 1 or 9, this is 7 or 8. 7 or 8 is only consecutive with 7 or 8 out of 2, 3, 7, and 8. So this must be 7 or 8. This must not be 7 or 8 to add up with 10 for the 7 and 8. This can't be 2 because of the 2 in the box, so this is 3, which forces this to be 7. 7's only consecutive with 8 here, so this is 8. This digit is either 4 or 7, and 7 can never be, well, 7 can't be here because of the 7 in the box anyways. So this is 4, which makes this 7 and 3. 3 and 6 add up to, or, in 1 to 2 ratio here. 4 has to be in a 1 to 2 ratio with 2 or 8, but the only one consecutive with 9 is an 8. So this is 8 here. This 3 is consecutive with 2 or 4, which either of those can be. But you have to have no repeats in circles, and we already have a 4 in a circle, so this must be 2. 6 is consecutive with 5 or 7, and this can't be 5 because of the 5 in the box, so this is 7. This can't be a 3, 7 pair because of the 7 in the column, so this is a 2, 8 pair. 3 is consecutive with 2 or 4, so either of those could be 2 or 4. This 3 eliminates 3, 7 as a pair here, so this must be a 2, 8 pair adding up to 10, and this 8 eliminates 8 here, so this is 2, which makes that 8. This has to be a 3, 7 pair here. 2 and 4 are in a 1 to 2 ratio with 1, 2, 4 are 8. And this 1 eliminates 1 here, so this can't be 1, that's 4, this is 1. This 4 eliminates 4 here, so that's 2. This can't be 1. 2 can only be in a 1 to 2 ratio with 4 then, so in that set, sorry. So this 2 eliminates 2 here, so that's 8 and 2. The rest of those digits in the central box have to be 1 and 9. Wait, does that work? Yes, 1 and 9. That means this can never be a 1, whereas the 1 in the circles, because there are no repeats. And there are 9 circles, right? 1, 2, I didn't even count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, there are 9 circles. So this has to be a 1, which is consecutive only with 2. So this is 1 and 2. 3 is only consecutive with 2 or 4. So that's 2 or 4. The last remaining digit in a circle has to be a 6. Because we already have 1, 2, 3, 4, 5, 7, 8, 9. So this is 6. That means this must be consecutive with 6, so it can't be 5 because it's next to an x, so this must be 7, which makes this 3. This 6 is next to a 4. The 2 cannot be here in this upper central box, whereas a 2, it must be along this x. So this must be a 2, 8 pair. The 8 cannot be here because of the 8 in the column, so this is 2, that's 8. That leaves a 7 in the rest of column 5. And the rest is, well, not, I wouldn't say Sudoku. We still have these Ren bands. Let's look at the rows and columns that have the most filled in digits. Okay, so row 4, we're missing a 5, a 6, and an 8. Well, 6 can't be either of these cells, so this must be 6 here. This then has to be 5 or 8. This 3 eliminates 3 here, so this is 5. 5 can be next to 4 or 6, but the 6 can't be there because of the 6 in the column. 8 can be next to 7 or 9, but 7 can't be there because of the 7 in the row. So this is 4 or 9. That means the rest is going to probably be just normal Sudoku. In this left central box, the remaining digits have to be 5 and 3. 5 can't be here because of the 5 in the column, so this is 3, that's 5. The rest of row 6, then has to be 4, 9. This can't be 4 because of the 4 in the column, so this is 9, that's 4. The rest of row 7 has to be 1 and 9. 1 can't be here because of the 1 in the box, so this is 9, which makes this 1. This 9 eliminates 9 here, so that's 4. 4 is only consecutive with 5 out of 5 and 8, so this is 5, that's 8. The 4 eliminates 4 here, so that's 2. The rest of column 1 has to be 5 and 9. So it's a 5-9 pair. The rest of column 3, well, let's just keep going in order. The rest of column 2 is 3, 6, and 7. This can't be 6, this can't be 7, this can't be 3 because of the 3 in the row, so this must be 6. 6 cannot be consecutive with 7 here because they would be orthogonally adjacent, so this is 3, that's 7. The remaining digits in column 3 are 4 and 8. This can't be 4 because of the 4 in the row, so this is 8, that's 4. Column 4, the remaining digits are 5 and 9. This can't be 9 because of the 9 in the row, so this is 5, that's 9. In row 3, the remaining digits are 8 and 9, and this can't be 9 because of the 9 in the column, so that's 8 and 9. That leaves us in this upper central box. The remaining digits are 1 and 5, and 5 cannot be orthogonally adjacent to the 6, so this is 1, that's 5. In column 6, the remaining digits are 6 and 8. And this can't be 6 because of the 6 in the row, so that's 8, which makes that 6. Column 7, we have 3 and 9 remaining. This can't be 3 because of 3 in the row, so this is 9, that's 3. This 9 eliminates 9 here, so it's 5 and 9. Remaining digits in row 1 are 1 and 6. This can't be 1 because of the 1 in the column, so that's 6 and 1. Remaining digits in row 2 are 2 and 7. 2 can't be here because of the 2 in the column, so this is 7, that's 2. We have 8 digits remaining. We have 8 digits in column 8. The last remaining digit is a 7, which eliminates 7 here, so that's 3 and 7. That's 3 in the corner. We celebrate because we're almost done, because this is 3 and this is 5. And that's how you solve it. Yeah, fairly straightforward, I guess. Yeah, just use whatever clues restricted things the most, really. And there were a lot of restrictions. I did miss this one very early on. That was the most restrictive, but you'll get there eventually. If you get stuck, you could probably find that pretty quickly. But this was fairly simple to logic out, I would say. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.